Let's look at vertex and intercept form of a quadratic function. So vertex form is when a function looks like this. So in this form, x and y are still your variables. A is exactly what it was before. It controls the direction and the width. So again, if A is positive, your parabola opens upward. If it's negative, it's going to open downward. If it is a value, or the absolute value of A is greater than 1, it will be narrow or narrower than the parent function. And if the absolute value of A is less than 1, like it's a fraction, 1/3, 1/4, it's going to get wider than the parent function. So those characteristics remain the same. But I've got two other numbers now. I've got an h and a k. And what do you think these reveal? Well, let's get some clues from the name. This is called vertex form. H and k are the coordinates of the vertex. So there is one thing, though, that you really need to notice. I always say opposite same. Like it's opposite of the value you see, because there's a negative here. So if it's -4, h is +4. And it's the same as the value you see here with the k. So opposite, same. So let's look at the 5 functions on your screen. They are all in vertex form. So let's start by listing the vertex of each. So what we're doing is we're identifying h and k. And like I said before, we're going opposite of the value we see, followed by the same. So I am highlighting h and k. So in the first one, my vertex is opposite same. It's going to be -5, -4. So opposite of +5, the same as -4. Opposite same would be +4, +6. Vertex on the next one would be -7, and then there's nothing in the k spot, so 0. Inside parentheses again, opposite would be 3, same as -11. And then the next one, there is nothing inside the parentheses with the x, so it's 0, -8, opposite same. Now, let's identify whether it opens upward or downward. And whether A is positive or negative will determine that. So the first one is going to open downward. Next one, upward, because it's positive. It switches back to negative, so downward. Then it's positive, so upward, and positive again. And then finally, is it wider or narrower? And what determines that is the absolute value of A. So if it's greater than 1, so in other words, ignore whether it's positive or negative, and just look at the numeric portion. So 2 is greater than 1, so it's going to be narrow. It's going to stretch it vertically. Next one is less than 1, so it's wider. Again, less than 1, wider. Less than 1, wider. And then greater than 1 is going to make it more narrow. Now, one last one that sometimes will trip kids up would be like if you had 4/3 times x minus 2 squared plus 7. This 4/3 is greater than 1, so sometimes you just get in the habit of seeing a fraction, but it's greater than 1, so this would be narrower. Okay, let's do a checkpoint. An application. The Tacoma Narrows Bridge in Washington has 2 towers that each rise 307 feet above the roadway, and that's labeled in my diagram, and are connected by suspension cables. Each cable can be modeled by the function 1/7000th times the quantity of x minus 1400 squared plus 27, where x and y are measured in feet. What is the distance between the towers? Well, this is a great question that really can be done by a lot of logical reasoning. So we've got this parabola here, and since it's given to us in vertex form, I use HK. I know that my vertex here would be 1400, 27. Right? So from one post or one tower to this would be 1400 feet. And if I want to know the distance between the two towers, by symmetry, I know that if I just double this, that the distance between the two towers would be 2,800 feet. So a little math and a lot of logical reasoning gets us that answer. Next, we're going to look at intercept form, which is where we have good old A is just what it's always been. And I have two open sets of parentheses. And I'm going to write this as minus P minus Q. So A still controls the direction and the width. I'm not going to go through that again in this video. And P and Q are the intercepts. Well, what intercepts? It would be the x-intercepts, also known as the zeros, and they are going to be P0 and Q0. Notice that they follow what's after the minus sign. So it's going to, both of these will be opposite of the value that you see. So something in intercept form looks like it's factored. So I'm just going to make a sketch from the function that we see on the screen here, and this is in intercept form. So the 3 tells me that it's going to open upward and that it's going to be narrower than the parent function. The intercepts are opposite of the values that we see. So I see x minus 2, so my first x-intercept is 2, 0, so I'm going to plot that here. And my other one is negative 6, 0, opposite again of what I see. So negative 6, 0. And one of the things that sometimes I'm asked to do is to find the vertex. Well, I just did a quick sketch here, but how you would find the vertex is the idea of symmetry here, that the vertex occurs halfway between wherever the x-intercepts are. So if I added my 2 and negative 6 together and chop that in half, that would be negative 4 over 2 or negative 2. So I know that my vertex is going to occur at negative 2. And then I could plug in to find the y value. And we'll look at that more in a future video, but sometimes that knowledge, just that logical reasoning, is really going to be helpful. So this says the path of a place-kicked football can be modeled by the function that you see on your screen, where x is the horizontal distance in yards and y is the corresponding height in yards. It says how far is the football kicked? So how far is it kicked would be, well, when does it come back down? So we're really finding, again, what is my x-intercept, okay? So I really have it given right here. It's the opposite of the value that we see. And I just want to point out, because sometimes kids are like, wait, that doesn't really look like it's in vertex form because intercept form, because I don't see two sets of parentheses. But if I rewrote this as x minus 0 because it's missing that set, then I think it's easy to see what's really happening here. All right, so how far is it kicked? It's just going to be 46 yards. Now, what is the maximum height? Well, the maximum height occurs at the vertex. And how do we do that? Well, again, we use this idea of symmetry, that it's halfway between my two intercepts. So if I have an intercept at 0, where it starts, and another one at 46, if I add them together and then cut it in half, the vertex is going to occur at 23 something. How do I get that something? I plug 23 into my function. So when I plug it in, I get 13.754, and that's my y value. So that would be the height of the football. So 13.754 yards. And this last thing we're going to look at is converting between our different forms. So in number 9, you should recognize this as intercept form, and we're going to convert it to standard form just for quick practice. My x-intercepts would be negative 5, 0 and positive 8, 0. This would open downward, and it is more narrow or narrower than the parent function. So to convert this, what are we going to do? We're going to multiply. Well, we're going to multiply any two together. I'm going to choose to first multiply my two binomials together. So I'm going to say that y is equal to negative 2 and I'm going to do my multiplication here, because I'm going to have to multiply everything by 2 then in the end. So x times x is x squared minus 8x, and then I'm going to distribute the 5, would be plus 5x minus 40. And I'm just going to bring down this negative 2, and I'm going to combine my like terms to get x squared minus 3x minus 40. And now I'm going to multiply everything by negative 2, which gives me negative 2x squared plus 6x plus 80. So here is my function in standard form. If I asked you to identify A, B, and C, you could. So number 10 is in vertex form. Just for practice, the vertex here, opposite same, would be 1, 9. Okay, so how do we change this to standard form? Well, I'm going to write out x minus 1 and x minus 1, and then I have this plus 9. So I can multiply x minus 1 times itself first and distribute, or I could distribute the 4. Just for sake, I'm going to actually distribute the 4 first. So it'd be 4x minus 4 in the first. Don't distribute that to the second one, okay? Some kids make a mistake. I think the easiest way to think about that is if you have 3 times 5 times 2, I hope you know you do 3 times 5 first, you get 15, and then multiply that by 2 to get 30. You don't go 3 times 5 is 15 and 3 times 2 is 6 and then multiply that together. That would be nonsense. All right, now I need to distribute. So I'm going to distribute the 4x to both terms would give me 4x squared minus 4x, and then I'm going to distribute the negative 4 to both would be minus 4x plus 4, and then I'm just bringing down this plus 9. And let me just give myself a little more room here. Let's combine all of our like terms to get our final answer of 4x squared minus 8x plus 13. Here it is in standard form. You could certainly find the values of a, b, and c for negative 8 and 13 once it's in standard form.